Hi students, welcome to Year 10 Science and Unit 1 Chemistry. We're almost at the end of this unit, but there's a couple of important concepts that we just need to cover before we finish up. So the important thing that we need to do in this particular video is to look at the factors that affect reaction rates. So in the previous video we looked at reaction rates as a general thing and why some reactions are very slow and some are very quick. This time we want to just look a little bit more at some of those specific factors that do affect reaction rates, and we're going to focus on temperature and catalysts and also talk briefly about concentration and pressure. So this is similar to a previous slide in one of the other videos. You can see that the important thing about chemical reactions is they occur at all sorts of different rates. Even reactions which are very similar, such as combustion and respiration. And effectively both of these have a fuel source, a carbon-based fuel. The wood in the case of combustion and glucose in the case of respiration. Each is using oxygen in order to help burn that fuel, and we're getting energy out as a result. Both of these produce energy. Obviously we're going to get heat and light from our combustion reaction. We also get this very important molecule ATP, which is the energy carrier for living things. And it's what we get out. Also, assuming complete combustion, we would get carbon dioxide and water from our combustion of wood. We'd also get carbon dioxide and water from respiration. So why do these reactions occur at different rates? Well, there are a couple of factors that affect reaction rates, and we need to have a quick look at those now. So there's three key factors that we want to have a look at. So we need to use, as we talked about in a previous video, we need to use the particle theory, that all matter is made up of particles. We need to use kinetic theory, that above absolute zero all particles are in motion, and we also need to use collision theory. And collision theory says that if particles are moving with sufficient energy and they bump into other particles at exactly the right angle, then they will cause them to react. So you'll get a chemical reaction. So these three important theories all contribute to why reactions occur in the first place. So it's useful to think about these in your explanation of why temperature, concentration or pressure and the use of a catalyst can help in each of these situations. The first of these is temperature. Now, temperature fits very nicely with our kinetic theory. And our kinetic theory says that particles that are in motion have kinetic energy, and if we add heat, then the heat will be converted into more kinetic energy. But more kinetic energy means faster speeds. In physics terms, it would actually be velocity, but it just means how fast the particles are moving. Now, if the particles are moving more quickly, then they have a greater amount of energy, but they also have a higher probability of running into other particles, of hitting them with sufficient energy in order to react. So temperature is really an easy one to kind of think about why increasing the temperature, adding heat to a reaction, can often increase the reaction rate. You're speeding up the particles, they have more energy, they bump into other particles more often, and you get a higher reaction rate. Now, concentration and pressure can be thought of as two similar explanations, two reasons that are very similar for why both of these things affect reaction rate. In concentration, we're looking at the number of particles in a given volume. And really pressure is also looking at the same sort of thing. We pack more particles into a given volume will increase the pressure. Just as if you add more salt to a certain amount of water, you'll increase the concentration of the salt. There's more salt particles in there. So if we had a certain amount of gas taking up a room and we pumped in more of that gas, we'd have more gas molecules, so we'd have an increase in pressure. We could, without changing the number of molecules, just put all of that gas into a syringe, for example, and squeeze the syringe so we compress the gas. That's pushing the same number of particles into a smaller volume. Now that is going to change its concentration, it's also going to change its pressure. And you see there's a relationship between concentration and pressure. The important thing is, just like we talked about with temperature, it's about trying to increase the rate of the collisions. And we can increase the rate of the collisions when we have more particles in a given space, and that will increase the number of opportunities they have to bump into other particles and react. Again, it's looking at probability. And the more chances you have for something to happen, the more likely it is to happen. At least it happens more often, and that's what we're looking at here. We're looking at the reaction rate. How often, when particles bump into other particles, do they actually cause a chemical reaction? The last one we need to look at are catalysts. Now, catalysts are chemicals which speed up the rate of a chemical reaction without actually taking part. They are not changed at the end of the reaction from what they were at the beginning of the reaction. Now, they can participate, they can actually form little complexes with some of the reactants, but they will eventually split away as the products are formed. One of the things that catalysts do is they help lower the total energy. So if a reaction has to rise to a certain energy in order to react before it starts to drop again, what the catalyst often will do is reduce the amount of energy for that reaction to occur. So a certain amount of energy less is needed in order for particles to react. Now, that could mean that it provides a surface. It may preferentially take one of those particles on and hold it so that it can react with another one. There's a lot of different ways that catalysts work. And really, it's probably, when we think about biological systems, better to say that they control the rate of chemical reactions, because some of them may actually slow the processes down a little bit. Some biological processes are slower than some chemical processes, and we saw that before when we were comparing combustion with respiration. And there are certainly a number of catalysts that are involved in the process of respiration. In fact, in biology, we call these catalysts enzymes. And they're a particular group of chemicals, of proteins, that are actually capable of acting as catalysts and being involved in speeding up the rate of chemical reactions. So these are the three main factors that affect the rate of chemical reaction. Each of these should be talked about in terms of the change in the factor and the change in the reaction, such as temperature affects reaction rate. Increased temperature generally increases reaction rate. So the difference between the relationship and the direction. So we'll have a look at a couple of examples, and we might even set you a little home task to investigate this. Thanks for watching.